Hey everyone, how are we doing? Let's do a little housekeeping to start. Oh no, I got the... There we go. Stream was going in the background. We're going to fix up. We've got the Chapter 4 homework and quiz and the second Canvas content. Let me look at the dates on these real quick, Tiffany. Oh, I've got so many tabs open. Too many tabs. Too many tabs. Okay. How's everyone doing today? I didn't ask how everyone's doing. Good to see you here, Trevor. Mohammed, good to see you here. Tiffany, good to see you here. Snea, good to see you here. Abigail, good to see you here. Tiffany, good to see you here. How's everyone doing? We're going to fix up some 201 due dates because we have a holiday. Oh my gosh, 4-day weekend if you have Haslam Friday. Who likes Haslam Friday besides me? Because today is Haslam Friday. We're almost done with the week. We are going to fix up some 201 arrangements of assignments here. 201, happy day for 201. We haven't covered this material for 201, so I don't like to do the material right after we cover it. We're going to go here to section 4. Let me look at when the Canvas content is due. The Canvas content is due on Wednesday, which we have class on Wednesday. So I'm going to push that to Thursday. My gosh. I think that'll be good right there. The bivariate visuals, and maybe I'll do part of that in class. So the Canvas content is due on Thursday. Actually, let's put these both to Thursday right here. Okay, let me change some due dates real quick. I'm changing due dates in Canvas as we speak. So that way we can have the day to cover it. That way we can have the days to cover it, and we don't do it like on that day, which we don't like to do. Bivariate visualizations. It's going to be a busy week next week. We're going to put this to Thursday. A lot of time right there with it being Thursday. The bivariate visualization is being moved to Thursday, and then we're going to do the homework real quick. Here we go. Bivariate visualization. Move to Thursday. I love holidays, but they always change the schedule a little bit. Haslam Fridays are the best. Thank you so much, Tiffany. Good afternoon, Hunter. Good to see you back. Been a minute. Yeah, Hunter, good to see you here. I'm still up with question 6. Oh, we can do that here in a second. We're going to take all the questions. Okay, we've got the visualization moved back. Let me look at the quiz. We're going to move the quiz back also, because we haven't covered this for 201 yet. And we'll be covering it on Thursday. And so let's go right here. And the quiz, we're going to move that to Thursday also. And so this will be on Thursday right now. Okay, that's moved to Thursday. That's moved to Thursday. Let me look at the due dates on the assignments. Okay, that's moved. Little tiny bit of housekeeping. I do know my Pearson. And let me go to Assignment Manager. We're fixing the My Pearson assignments right now. And let's go to Manage. We want to edit dates and statuses. That looks a little bit weird right there. Edit dates and statuses, I think. What questions should we do next? What questions should we do next? My Pearson's been a little bit slow lately. The Chapter 4 homework is due on the 7th. If we had just gotten to that, but no. It's due on the 7th. I'm trying to think when it should be due. We have the 14th. My Pearson's been so slow lately. If we can do 9 for lab. I think we did that earlier today. I think we did number 9. Yes, with the fractions. We did number 9 with the fractions earlier today. So we have that in the office hours from this morning. So we might loop back to that. Trying to change. My Pearson just got weird this semester. They updated their UI and it's like so much slower. I might have to update each of these individually real quick. We're going to update this and we're going to start doing some questions. Assignment settings right here. It is so slow. It's incredibly slow. So right now it's due on the 7th. Let's put it due till the Sunday. Save and assign. Okay, that one's fixed. That one's now due on Sunday, giving some more time. And then also right here. Good, that's fixed. And then Here we're going to go to the assignment settings here. I have one more class to fix after this, sorry. It's funny, like I can click on this a lot faster. It just takes so long to load, and my Pearson used to be so much quicker. Okay, that is fixed right here. So we got one class fixed. This is section 4 fixed. And let's go to section 7 and fix their assignments. And we should be good to go here. I think Tiffany had a question to start for 201. Tiffany, can you repaste your 201 question? And we will do that here. And let's go here to settings. I always want to space stuff out as evenly as possible. And especially with the holidays, with the day lost, we don't have a day to lecture it. Oh, my Pearson load. This used to be so much quicker. I'm literally clicking on it. I'll show you in the background right here. I'm literally clicking on it. So I've got it over here on the other screen right now. Oh, I'm not even on the screen right now. So I'm literally clicking on it and going to assignment settings. Best office hours ever. Sugar is a major component. Let's deal with next here. My Pearson, what are you doing? Oh, really? The page is going to load when I do that? They changed this new platform and I don't understand. You go to assignment settings. There it's loading. New date, save assign. Okay, we got it. Now we go to the other one and we go to assignment settings. Okay, now it's doing it. Okay, thank you, my Pearson. Thank you. You didn't used to take this long. Save and assign. Good to go. Got it done. Finally loading. They changed to these sorts of buttons and it just takes way longer. Sorry about that. Right there. Actually, I kind of needed that. Let's go back in. We're going to do... So I was doing that in the background right there, getting it changed up. So Stats 1's got a little more time on those things. We're going to go back over here and we're going to look at the sugar as a major component. My access has been denied. No, my Pearson, no. Let's get some my Pearson up. I'm literally having to reload. Who's ready for some Tennessee football tonight? We are playing Bowling Green. Let's put a little chill music on right here. We are getting the first assignment up with the sugar being a major component. Quiz number 4, I believe. Sugar is a major component of all breakfast cereals, if you didn't know that. Yes, it's working. Sugar is a major component. Let's go find that. We found it. Here we go. Did you say that Chapter 4 homework and quiz is now on the Sunday the 12th? That is correct. Just pushing it back because usually we have them due during the week, but since we have the holiday, just giving more time, we will cover it incomplete. We will cover it completely next week, but I wouldn't want to do it Wednesday, and there's already assignments on Thursday and Friday. Generally, there's smaller assignments, so just kind of space out your work and work ahead. Yeah, a lot of work. Let's go check out sugar as a major component. Here we go. Next topic, new topic. Sugar is a major component, Stat 201, Chapter 4. Sugar is a major component in many breakfast cereals. The histogram displays, so we have a histogram and bar chart. Is this histogram 1 or 2 variables? Be careful. Is this histogram right here 1 or 2 variables? Is this histogram 1 or 2 variables? Is this histogram 1 or 2 variables? Is this histogram 1 or 2 variables? Is it a univariate or bivariate display of data? Is that histogram there 1 or 2 variables? It's actually just 1. Now we can do things like stacked histograms. So a stacked histogram would be 2, where we stack the histograms on top of each other. So the histogram right here is just 1. I'm gonna throw some 50 points. People helping out, Snay, and other people practicing right here. It's actually just 1. But the box plot, I almost got it wrong. The box plot is actually a bivariate display because we can see here, was it an adult or children's cereal? And then we can see the percent of sugar in them. So we have here a bivariate display where we know the question of what kind of cereal was it. So if we had a cereal like, is that really? Oh, that's the highest number for the children's. That's probably like, oh man, Rice Krispie Treat cereal. It's a good cereal. And then the lowest children's cereal might be something like Captain Crunch. Probably still has a lot of sugar in it. This is probably like Fiber One. Fiber One's horrible. And then this might be something like Honey Nut Cheerios, an adult cereal that has a good bit of sugar. But you can notice, what we notice for the children's cereals, there's a lot more sugar than compared to the adults. It's also telling us the lowest value for the adult cereal is 1 gram of sugar, and the highest value for the children's cereal is 85 grams of sugar. What is the range of contents right here? Or 65, excuse me. What is the range of contents for sugar? So we need to go from the max to the min. Now, don't be tricked. If you look over here, it looks like it might be 0 to 70, but that's not the answer. What is the range of content for cereal sugar? So it's the maximum number minus the minimum. Remember, these are bins which collect the data. So you can see there's a bunch of low sugar cereals, but what is the minimum value? And there's very few high sugar cereals. So what is the maximum? This is like all sugars together, like children's cereals and then adult cereals. This is every one of them together, and then we split them apart in the side-by-side box plots. So what is the range of the values? It goes over what percent sugar? Really, 65% sugar? Is that like sugar with a little bit of cereal? That's crazy if that's true. What is the range of these values? The max minus the min. The max minus the min. What is the maximum minus the minimum value? So for the range of the values, we always want to go the maximum minus the minimum. So what would we get here when we do the max minus the min? So what would this equal to? The range of the values is always the biggest number minus the smallest. Now, don't be tricked. Don't look over here. These are bins. This tells you that there is observations between 60 and 70. There are observations between 0 and 10. Let me go to live chat. Nice job, Tiffany, right there. Tiffany, everyone, another 50 points right there. Remember, practice along. I wasn't on live chat. And so we see right here, the range is 64 because it's just 65 minus 1. That's the range. This is just bins right here. There's data between 0 and 10. There's data between 60 and 70. The highest value is 65. That means the value of 65 is contained in this bin. It doesn't have to be 60 or 70. The shape of the distribution, which is best seen by the histogram, important to know that, is bimodal, meaning there's two modal areas. Can we go over question 5 on the lab? I bet we can, yeah. We've got a lot of questions stacked up. We'll definitely do it. Keep putting those questions in here. We'll do as many as we can. We've got another hour and 15 minutes. What aspects of breakfast cereals might account for this shape? Well, look, we have adult cereals and we have children's cereals. So generally we have what? We have cereals tend to be either very high sugar or very low sugar, and it looks to be based on if it's an adult or children's cereal. Are all children's cereals higher in sugar than all adult cereals? And the answer is most definitely yes. This is the highest adult cereal. This is the lowest children's cereal. So the lowest children's cereal is way higher than the highest adult cereal. So most definitely yes. What group of cereals varies more in sugar content? Ooh. So the larger, let's see right here. Although the range appears to be comparable for both groups, the IQR is larger for the children's. Ooh. Which one of these has a larger IQR? Now the ranges might be quite similar. Let's draw on this. Here's the rabbit. There's a rabbit. Although the ranges might be similar, and here's the range. There's the range. So which of these, that's the range, which of these has the larger IQR? That should be pretty obvious. Although the ranges are pretty similar, and this is adult. Although the ranges are pretty similar, which of these appears to have a larger IQR, which is more spread out? The data is more spread out for this group then. So this is the middle 50%. The one on the left, right? Exactly. So the adults ones have a larger range, so it's more spread out. So although the ranges are kind of similar for these, let's go look at this. Although the ranges appear to be similar, the IQR is larger for the adult cereal right here. I think we've done everything properly. Yes, we have. Good stuff right there. Good stuff. Let's do one more 201 question, and then we'll hop to some 474 questions. Let's do it. What is the next 201 question? If you have a 201 question, put it in the chat. We'll do one more 201, and we'll go back and forth between stuff. But what other 201 question are you wondering about? Practicing interpreting data right here, interpreting box plots, interpreting histograms. What other 201 questions are you wondering about? 201, you've got the floor right now. We'll do another 201, and then we'll hop to doing probably some lab, or we've got a lot of homework questions. Great stuff right here. When you take a vote, I see Abigail wants number 5 for the lab. And then Mohammed's wondering about question number 2 or question 4. Question 4. A consumer organization compared gas mileage figures for several model cars in country A and country B. So country A, country B. Let me go find it. I'm looking through it right now. I have to go find the question. Found it. Let's do it. Here we go. New topic. Stat 201. A consumer organization compared gas mileage. Let's go check it out. Now, I'm not the biggest fan of back-to-back stem and leaves. They have appeared on the test, and you should know how to read them. So what we're looking at right here is this is country A, this is country B. And when we look at this, we need to be able to see these numbers up here in country A and these numbers here in country B. So where is, and let's look right here, where is 36.8? 36.8 would be in what country? 36.8 would be in what country? 36.8 would be in what country? And what you have to do is you have to round it. So 36.8 would round to 37. So 36.8, which rounds to 37, would be in which country? So 36.8, which rounds to 37, would be in which country? Country A. So it rounds to 37. So I want you to notice that when we look at this key right here, it's a very complex key. All this says right here is when we round it, that we will then just use the number, like this would be 27 right here. So when we look for this 36.8, that rounds to 37, and it's in country A. Here it is right here, and here it is right here. Guess what? We've narrowed this down to 2 graphics. We've already figured out that graphics C and D are wrong. And let's look down here. We have some key differences in the bottom. Now, if this graphic is right over here, I should see something that rounds to what in country B? If the graphic is right, if this one, let me circle it. If this one is correct, I should see with this number right here, something that rounds to what? Or something that rounds to what in country B? In country B, there should be observations that round to what? If it is correct. If it is correct, I should see things that round to what numbers for country B? If this is correct, like this number right here, if this is in country B, I should see something that rounds to what? 11 or 12. Tiffany, great job. Tiffany, 50 points. Excellent job following along. These are tricky to read. I understand. It's like, wait, what's going on? This is an observation in country B that would round to 11, and take a look. It's not there. It's just flat out not there. So that means this is wrong. We don't see that occurring. If you check over here, you will see values of like things that round to 11, things that round to 12. We're just showing these values right here. Things that round to 13. That rounds to 13. If you were to check another value that appears over here that doesn't appear in the other one, these have to be in country B. Things that round to 17. So where's my 17 rounding? That rounds to 17. Things that round to 19. One thing that rounds to 19, like an observation that would round to 19, and that's right here. Is this making more sense how to read this, Tiffany, right here? Like look for the specific values and try to eliminate graphics and be like, do I see something that rounds to this in this country? And just look that it rounds to it. They wrote it a complex way over there. It's just whatever it rounds to. So they're just rounding it to 1 digit, and we can see what these numbers represent. That's probably one of the hardest parts of this question, is reading the graphic and understanding which one you're looking at. Pretty tricky stuff right there. From here, we just have one more question. Which of the following comparisons is correct? And if you look, country B looks to have water gas mileage. Is this gas mileage? It's gas mileage. Country B seems to have higher gas mileage. So the models for country A, no. Models for country B, models for country A have lower gas mileage than models for country B. And I think we've done it. That's got it. Important to be able to read and interpret this data. Now, this is not on my chart. This is a back-to-back stem and leaf. And back-to-back stem and leaves would be like side-by-side or stacked histograms and side-by-side box plots. Exactly. And is that making sense there, Tiffany? Excellent work, Tiffany. Great practice, great questions. And just understand that a back-to-back stem and leaf is bivariate with a quantitative variable in the Y, because we're displaying this, and then in categories right here. So these are back-to-back stem and leaves. Little tricky to read, and good practice right here, being able to identify that there should be 2 things that round to 36. And the two things in country B, that round to 36 are this one, and the other one in country B that rounds to 36 is this one. There's the two things in country B that round to 36. So practice being able to read the graphic, being able to understand it. It has appeared on the test. It's not a common question, but you never know what there's going to be. I think we had question 5. Cora, good to see you here. Hello, Cora. Good to see you. 20 points for Cora appearing. Let's go check this out. So I think we had, could we look at number 6 on the homework for 474? I'm not sure what I'm doing wrong. Yeah, let's look at some number 6, then we'll go back and do the activity. So number 6, Josh, great time to ask the question right there. Let's take a look at number 6 on the homework for 474. Remember, I do similar work. I might not solve the whole question. Sometimes I solve it, sometimes I don't. You never know. Here we go. We're looking at subsets. So I'm not going to do the full subsets right here. Okay, let's talk about the important way to subset. This is for 320 and 474, how to write subsets. And we're going to do the lab next. You got it, Snay. I think other people are running too. So this is new topic. Next topic, how to subset. And this is very important. Let's go check it out. So one thing I noticed is when people subset, usually they write the full subset out. Here's the 2 mistakes people make. 1, trying to do all conditions at once. That's a big mistake. 2, not using pretty syntax. Let's say nice coding. So I was a big offender of this. I didn't space my coding for a long time, but it makes it way easier to read. We'll check that next year. Awesome questions, everybody. So I was a huge offender of this, making my code look ridiculous, and it was way harder to read till I started trying to make my code spaced and make it look really nice. So if you notice right here, when we start by taking a subset, especially if you're just learning how to do it, I ask that you just start by doing this. Let's run all chunks above just to get everything loaded in. And then let's go here and store into subset movie. What's going to be in the sub right now? What is going to be in the sub? Since there's no conditions, what is going to be in the sub? What is going to be in the sub when I run this with the environment loaded in? What is going to be in the sub? Everything, right? All of the data frame movie. Great job, 20 points right there, practicing, following along. The full everything of movies, right? Because we don't have any, good to see you here, William. We don't have any whats. We don't have any whats right now. Brian has not written a single this to subset on. He's not written a single, think of a C word, like you're working out, you're conditioning. I have not written a single what to make subsets. And I might write the most complicated one, condition. I have not written a single condition. Now, when you write conditions, you want to start by writing just one condition. Remember, we're going to hit comma. This is going to bring us into the condition area to do conditions. Great job, Mike and Snea and Cora. Great work. So now we're doing conditions. And I want you to notice I hit enter to go to a new line. Now I'm going to write the most complicated condition that a lot of people are doing more complicated. We want that ratings, and let's see how ratings is spelled. Does everyone notice here rating has a capital R? Make sure you spell it that way. If you do it this way, which I don't suggest, it's not the end of the world. You will be able to spell rating. But since we're already inside a movie, you don't actually need that, but you don't get the autocomplete. So I do understand why people do that. You will get the autocomplete. I've seen a lot of people working on this problem who are doing that rating is equal to G, or rating is equal. Just one moment. I know. Is equal to G, is equal to PG, or that rating is equal to PG-13. Now you have to be careful right here. This condition kind of will work right now. Let's see if it worked. Let's look at the sub. Let's go to the rating. We haven't taken specific columns right now. And if we go to the rating, it looks like we only have P, PG-13, and R. Is that the ratings we took? G, PG, and PG-13. So we don't have the R ratings anymore. Which, how many ratings are there? Levels, movie. I actually just have a better way of. Ooh, there's a lot of ratings. So yeah, it's gonna be better if we just do this. Okay. I was thinking we could just do not R, which we can't. Okay. This is one way, but if you do this, you probably want to put this all into a parentheses so it evaluates as one thing. because you have to be very careful, and I'll explain why. If I do the code this way, and we have the year, and I say year equals to 20, the movies I don't think are that recent, 2002. This will give me a subset. What did I do? Oh, and. That's why you code in little bits. Snea, that's the way we're right about to do. Yep. Snea is totally right. We'll take a look at this subset right here. I guess no movies came out. Really? There we go. Whoa, 2002 must have been a bad year for movies. These are movies from 2002 that have these ratings, and we could put to the box office, to a high box office, to actually see big budget movies that we probably would know. And these are the movies like Lord of the Rings, Return of the King, Finding Nemo. And these are movies from 2003, gosh, I feel old now, that had PG, PG-13, or G ratings. But be careful, because if you do this right here, I want you to see what happens to your subset, and I want you to think about what you actually have. If you run this, watch my subset, and this is the common mistake I'm seeing a lot of people making. If you run this, watch the subset. Do you see it? And what are we actually getting? What we're actually getting might be better syntaxed like this. What are we actually getting now? And be very careful, and this is why I put this into a parentheses to evaluate as one condition. And then we're going to look at Snea's condition right there, because that's a way better way to write it, which is what I would suggest. What are we getting when we have it like this? Which is, I have it syntaxed the way that kind of makes sense to read it. Be very careful. What are we getting right here? With this, we are saying take a subset of movies that are of year 2003 and G-rated, or it could just be PG, or it could just be PG-13. These are not connected now because of the ors right here to the 2003. Does that make sense? I think this is where a lot of people are getting tripped up. If you say you're following along the year from the question, exactly, is different. Cora, I'm throwing Cora 100 points right there. That's a good thing to note. Cora, great job. Make sure people know that Brian often works similar questions, but not quite the same question. Cora, thank you so much. Earning everyone a big 100 points right there. It would do year and or, exactly. So this says, get movies from 2003 that are G-rated, or it could just be PG, or it could just be PG-13. But if you do, and I think it's better if you syntax it this way then, we're going to bring this back on this line. If you were to then put the parentheses around this, which is an okay way of doing it, you will get now a subset of movies that are from year 2003, and then this whole thing evaluates as one condition because it's in a parentheses. Does that make sense, William and everyone else? Now this is evaluating as one condition because I'm having that evaluate by itself in one parentheses, not we want this and this, or this, or this. We're saying we want this and this, or this, or this, or this. Because this is all evaluating on itself before it hits the and. Like this is one thing right here. It's literally just one thing, and it's connected to the and. It's not doing ors outside of it. Does that make sense? That is where I think a lot of people have gotten tripped up. And Snea points out such a much easier way of doing this, because what we could do is we could go right here and we could do rating, and we're just going to remove the parentheses now on this. We could do that rating is contained in, and we could go right here and just take this vector and go and write this. And I'll show you an even cooler little thing we could do. So now we have here, and it's PG-13, right? So now, and look, PG-14, what? Now it's 86. When I run this, we get 86 movies. When I run this, we get 86 movies, and that confirms we're doing the same thing. You could always do this, though. You could say rating interest. And now, and this is similar to other things we're doing, I can just put rating interest right here. So now I could adjust this outside the subset, so that way the code is a little more concise. Not that you have to do this. And we wouldn't want to, technically, know what's interesting? If you do that right there, that creates a very, very interesting format. This is not a good way to do it, and I like that you pointed out. What this will do right here, and this is a little confusing, so listen closely. When we do the subset, it'll look to see if the first movie has a G, and if the first movie has a G rating, it'll put that movie in the subset, and it's 2003. If the second movie is PG, it'll put it in the subset. If the third movie is PG-13, it'll put it in the subset. If the fourth movie is G, it'll put in the subset. If the fifth movie is PG, it'll put in the subset. If the sixth movie is PG-13. So it's going to keep checking this for each movie, but it's going to move the position. We want that the rating is contained in the ones we're of interest of. So we don't want the equals because that'll do a kind of like, what am I trying to say here? A sequential check. It'll check this one versus this one versus this one versus this one, and then it'll repeat the vector across. You'll see here we'll get a different, get 25 right here. So we'll do a item by item check, and we don't want that. So this one, and I like that. Josh, so good for asking that right there. Just the little things right there. And so when you're doing this, just do it in these little bits. Tiffany, great job. Another 100 points for Tiffany right there, getting the 100. We're just going crazy on the points. Hashtag show up, get these points. Hashtag show up, get these points. We've done most of this question right now, I think. We're going to go do number 5 here in a second. Print to the screen, these sorted. So if you want to sort something, real quick on how to sort something. Sorting is using the ordered function. So you want to use order, not ordered, but there's an ordered function. I haven't used that. Oh, it's for factors. So many points. Hashtag show up. And so this will give us the order by which we should report things, such as if you want to look at the runtime ordering, we can go here. We want to go to the subset. Now, I'm not doing your exact same question. We can go here to runtime, and this is the ordering of the runtime, and it's going to then be used as positions in the subset. And this is the way I like to do it, is 2 lines of code. And there's that. And here's the runtime of the movies ordered. And let's store the sub. We'll call this sub ordered. And you can see our subset is now ordered by runtime. If you go over here to runtime, is now ordered by runtime. We actually have it with the increase or decreasing equals false. I'm going to change that. I'm going to change the way it's ordered with decreasing equals true. Now let's look at the sub ordered. And the longest movie right here was Hulk. Not bad movie, Eric Bana. That was the longest movie. Yeah, we saw it with my cousin. Gosh, went to the lake house then. Missed that. Not like we own a lake house, but we rented one. Missed that. So we'd be like my family, like my aunts and my uncles would all get together. Oh my God, my parents were only 53 and I'm almost in my 40s. Ah! Gotta stop thinking about this stuff. Gotta stop thinking about how old I am and how old my parents were at that time. Okay. Back to the world. And look at Hulk did not do so good at the box office. Not when Marvel was in its stride. When Marvel was making the same movie 50 times, but we love that movie. Check out the new Marvel movie. It looks pretty good, getting good reviews. Yeah, check it out. One last thing I want to mention is if you don't want all those rows, all those variables, you can use the select. We should be doing select equals. Let's just go movie and let's go budget. So now we should just have in our subset the movie and the budget, and we do. So this is the movie and just the budget, and I think it's actually mad because I don't have a budget variable in there for it to order by. So if we are ordering by something, we need that variable. This is the power of coding, once again, because if we're doing this right here, we can make it so we can change things pretty quickly and pretty easily. How's this looking? Are people getting this? Do we have time? We can start some Canvas content too. I think we can do that after we'll do the activity. So Tiffany, great question. How are people doing on their subsetting? Is it making sense? And please note, I followed my rules right here. Don't code all your conditions at once and use nice formatting to make things easier to read. And if you just practice, hey, Forrest, what's up? Oh, Forrest right here. I'm going to go on a limb. I'm making Forrest a mod right here. I remember Forrest right here. So good to see you. 50 points for Forrest swinging by right here. Thank you so much, Forrest. You're now a mod, and so good to see you on the channel right here. Thank you so much, Forrest. Some positivity. Go Vols on Tennessee Football Day. Are you near graduating, Forrest? Congratulations. If so, we're going to go back here and do some BS 474 activity. And then, Tiffany, we're going to do some Canvas content too. Okay, let's put on some tunes right here. Let's start this up. With this, let's listen to some 80s music. Here we go, some 80s music on Stat 201. Let's start this up. And I'm hitting random buttons. Let's get that activity going. Activity number 5. Question number 5 on the activity. For loops over categorical variables. Let's go check this out. This is a lot like homework assignment 320 if you're listening up. New topic, 475. basically like your homework for 320 and 474. Junior year, you got this, Forrest. Keep strong. You got this. Keep great work. I love it when people swing by and are like, hey, Brian, just swinging by. It's awesome right there. Although this task, 4 loops over categories. Although this task may be easily accomplished with this. Here's the good news, is if this basically gives us the answer, we're good to go. Those might have the answers to the question. So let's take a look. Use a for loop to populate the elements of a vector name average tip with the average tip percentage for each day of the week in the weekday column of tips from the dataset from the library reg class. You can verify the numbers by looking at this. So there's the answers. And let's try this here. You ready? So what is library reg class and what do we need to have to run library reg class? Who knows what we need for library reg class to run? It's a good question. No, this is exactly it, Sned. This is really good practice. Who knows what we need for library reg class to run? Like if you run library reg class and it doesn't run, which mine will, what do you need to first do to have library reg class run? Because these are the libraries where you're accessing things. These are your libraries that are currently loaded up. And notice how I have reg class loaded up. Install.packages reg class. Abby right there, 20 points, great answers. You need to install.packages reg class. If you ever try to load a library and it doesn't load, install.packages reg class. Just these little things that we need to know at all times. Great job, Cora, there also. So if this doesn't load, run install.packages. I'm just going to comment that out. So now we are loading the tips data frame. You can tell that the tips data frame is inside of reg class because when you do data tips, it'll say reg class next to it. And this is a preloaded data set. There's lots of preloaded data in R, even by default. These are all preloaded data sets like the BOD, the CO2, the Chickweight, the DNAS, the Johnson data set, used that one a lot in time series. These are all preloaded data sets. They are not files on your computer. I mean, they are a little bit, but they're preloaded data. They're like pre-installed games on your computer. You're not loading a CSV file here, which is like loading an Excel file. When we submit the homework, do we need to submit both the R and the knitted file? Just the knitted file. Just the knitted. Carly, great question. 20 points, Carly. Just the knitted file. Just the knitted file. Just the Word document. Great question. And so now that we have the data set loaded in, let's think about this. So what do we want to do? We want to take a subset of days. Whoa, this is coming back to be what we just did. So let's try to take only the tip percentage for Saturday. Let's take only the tip percentage for Saturday by going and taking a subset of Saturday. How could we take a subset of Saturday? Just start me out here with just a little bit of code, even the most very beginning. I want to subset the tips data frame. So get me started and I'll write the next part. So I want to subset the tips data frame. Any sort of code at all. I want to subset the tips data frame. I want to get only the tips for Saturday. Subset right there. Let's store sub into subset. And let's take the tips data frame. Boom. Now, once again, this is a full data frame of everything. We need a what now? So we don't have a subset yet. I mean, we do, but it's the full data set. So if you look right here, this is the full data set. We'll just remove the environment for now. This is the full data set right here. This is everything. We haven't written any whats. We haven't written any whats right now, which we probably need. Conditions. So the comma is going to be a new argument. I like to hit enter to get nice syntax. And we are going to take only, and let's look, on weekday. And I know you're like, weekday, what? It is called weekday equals equals. Now be careful. This probably won't subset. It says, Saturday not found. Saturday needs to be in quotes, and then it'll find Saturday and look. All of a sudden, now you have a subset. Always look at what you make to confirm. Be like, yep, that worked up there. I can see that that is working. I'll look up there. So that is working. We have a subset of only days that are Saturday. We're almost there. Now that we have a subset of only days that are Saturday, we just want to take the what. We're so close. We just want to take the what of days that are Saturday. The blank percentage. Just talk to me in words. Be like, well, we actually want to find the, for those days, we're actually trying to find the The mean tip percentage. Great job, Lucy, right there. 20 points, Lucy, jumping in. Yep. The mean tip percentage. So let's go here to mean. And remember, we are using our subset because this is only Saturdays, and we're going to tip percentage. And there's the mean tip percentage. Is that the right answer? Let's look at our key. And Saturday is 15.36, and there it is. We got the right answer. So we do have the right answer, and this is very similar to ones we were doing last night on the activity. So with this right here, we have the right answer, but let's store this somewhere. Let's go here to mean tip percentage. I'm going to initialize a blank vector. And here's where your mind just might go, what? Am I the only one who gets this reference? Oh my God. Everyone, half the class is probably like, what? And 180s person will be like, knows that 90 reference. I'm probably doing it horrible. Let me try again one more time. No. Or people are thinking Scooby-Doo. Probably like, Scraggy. No, it's totally different reference. I'm just losing my mind slowly. People are saying Scooby-Doo. I'm trying to do a home improvement reference. Tim the Toolman Taylor. Can we find it? YouTube. Tim the Toolman Taylor grunt noise. Oh, it actually exists. I think every grunt. Oh my God. What have I done? There it is. There it is. That's it. That's it. That is the iconic noise. I'm going to play it one more time. Oh my God. What have I done to us? What have I done? I'm going to get copyright claim by the 80s now. Yeah, it's in the theme song. It's literally at the end of the theme song. It goes, I don't know. Anyways. Fun's over. No more fun. That should be in the 90s, I think, right? Was that 80s? That's 90s. I think. Tim the Toolman Taylor. Tool Time. Home Improvement. Whew. Okay, we're storing into position Saturday. And so what have I created here? Back on track. Brian has created a what? I am creating a vector. But what kind of vector am I creating right here? Brian is creating a vector. Brian is creating a what kind of vector? It's looking for the average of Saturday tips. Would you explain why I've never... Oh, there you go. Okay, that's fine. Yeah, that could be it. Yeah. I'm a 90s kid. Yeah. It's a show that's like... Go watch Full House or something if you want to watch something from the 90s. Full House. Family Matters. Go watch Family Matters with the Winslows and Steve Urkel. Family Matters is where it's at, or like Sister Sister, some good stuff from the 90s. Number 7, we could. We might have done it earlier. We're gonna do Canvas content here after this, but we might circle back, Hunter. Great question, Hunter. So what has Brian created right here? What is this called? I need to know what I'm creating right here. I didn't exist in the 90s. Oh no. I was in high school in the 90s. My brother started college in the 90s. I'm old. I am creating the skeleton, correct. I am creating the skeleton. So yes, this is the skeleton, and this is a named vector. So the vector actually has names because I'm naming the position. Position 2 is Sunday, and we basically almost have the loop. What we can do, watch this, is we can go right here, and I can just call here day o week. If you were at the activity last night, you might have saw something similar to this. Day o week is going to be called Sunday, and let's just change this to day o week. And now when I run this, it still runs because day o week is Sunday. And then I can just change this to Saturday. I can change this to Thursday. I can change this to Friday. And we've done it. But the only thing we haven't done right here is we haven't created the for loop. So if you notice where the skeleton is at, watch out. Let's check this out. Week. It can be called anything. Cora, 20 points right there. Correcting some typos for Brian right there. Day a week. Still works. So the skeleton right here is on lines what through what? Where's my skeleton? Be very careful. Where's my skeleton? What line through what line has the skeleton? You might be careful. What lines through what lines? And we'll do Tiffany's question here coming up next. What lines through what lines have the skeleton? Where's the skeleton? The code that repeats. Now, I know. That's Snea. What lines through what lines have the skeleton? I think, Snea, you're right. And where does it start? You are correct. You are correct. Where does it start? It does go through 136. You are correct. Where does the skeleton start? Not 132. The skeleton starts at 134. And I'll explain why. So I just want to make sure people see. And I always like pause to ask a few questions right here. Skeleton and William right there, 20 points. Thank you, William. Remember, we get it wrong in here to get it right on the test. So we're going to go right here and go 4, and we're going to drop the skeleton in. You can also reformat lines by going to code, reformat code lines. I missed Control-Shift-A. I got to remember that. And that makes it look a little more pretty right there. So, hey, what's up, Brandon? Good to see you here. And so check this out. When we run this, what is the name of my variable? What is the name of my variable? Who remembers my variable name without the typo now? Exactly, and this is what we're going to see right here. Snea, you got it. This is what we're going to get. I think Snea is seeing it. What is the name of my variable? What is the name of the variable I am using as the placeholder? What is my placeholder variable name? Day of week. Now, what is that going to go through? Be careful. Day of week is going to go through what? Day of week is going to go through what? It's going to go through, and there's a few ways to do this. We're using the tips data frame. We're using the weekday. You don't want to do that because this is a ridiculously long vector. Remember, it's going to run, and the answer is down below of what it's going to go through. What is day of week going to go through? Not the sub. You're close. The answer's down there on the bottom. Day of week is going to go through what? You're really close. Day of week is going to take on the values of what? Great. Yep, you see it. Excellent work, Snea. Another 20 points for the class right there. You're totally right. And Thursday through Sunday. And you can confirm this by running this just by itself. Always run your code in little bits to make sure you're seeing what it's going to do. Remember when I was running this just a moment ago, I was inputting Friday, Saturday, Sunday, Thursday. So we could reinitialize a blank vector right here just to see if it works. And when we do this, at the end, we can look to see if it works. So this is just the initialization of a blank vector. It just clears it out. And then we're going to run this right here. And then we're going to look to see if it created, and it did create. Who feels like they get this? How do you replace NA with a median in general? You want to find those NAs, really quickly on that, just briefly. You want to find is.NA of whatever's inside of X. You want to find the positions of things that are NA. These will find you the positions. You want to go to those positions in X, and then you want to store the median, but you might need of X, but you might need the NA.remove equals true on. Kind of a quick hint right there. But I didn't think, awesome. So you want to find out if something is missing, find the positions of the missings, go to the positions of those missingness. I think we can, Edgar. Yep, we'll come back here in a moment. We've got a little more 201. Tiffany, thank you so much for the question right there. But how are people feeling on this? A little quick shout out right there, because how do you replace with the median? Make sure if you have NAs, you need to use the NA remove equals true. So that way, if you don't run this, you'll get NA for the median, and then you'll replace the NAs with NAs. How are we doing on this number 5? How are people feeling? I think we're going to do Tiffany's question next. We'll head back to the main screen. We've got a lot of time left. We got 40, 50 minutes, something like that. 40 minutes. 80s classic music. Let's head back to the main screen. Edgar Snea, HTT, good to see you here. Next question on the docket is a little 201. Tim, what do you think about that? Tim Toolman Taylor talking in the background. Tim Toolman Taylor, sorry. You got to go away for now. Let's see. Okay. What is that? Let's take a look right here. Lock. What? Oh, I made a mistake. Saving. There we go. Okay. Let's go take a look at Canvas Content Quiz 2 for Stat 201. Canvas Content Quiz 2 for Stat 201. The Chapter 3 and Chapter 4. Here we go. Canvas Content Quiz 2. seemed doable, but then I saw this one and my brain melted. Oh no. No. If you watched the activity last night, you literally saw my brain melt live. You do too much coding, you gotta step back, you gotta take a break. It's literally like sitting down and saying, I'm gonna get big muscles in one day, which is what I try to do. I just sit down, I'm gonna do like 200 lifts. You're gonna hurt yourself, you're gonna get tired, your brain's gonna overheat. Well, when you try to code that much. If you try to lift that much, you're gonna hurt your muscles. I think Tiffany's question was... Cora and Snea, great job right there. It's all about those little bits. I need to email about that too. We decided not to move back due dates because we were talking in an email. We're like, it's going to set the precedent that we're going to move back due dates. So especially on the day of, we don't try to move back due dates. We might move it back like days in advance, but usually not the day of. What is the 75th percentile for the French team? Let me find one of those that says that. So we try not to move things. Oh, I just reloaded the chat. I'm going to try to find Tiffany's question right here. Top chat, no live chat. Do you know if we will see our grade before tonight? Let me email them. We might try to make changes to that because I could see the whole problem. I might be against that, Cora, because let's say like someone in the first class solves everything and then they know they have 100. Then people might just send out the answers to be like, hey, here's all the answers I put in. These are the 100 answers. So I think no, like does that make sense, Cora? I know that it's kind of a bummer. It's just waiting till everyone has it graded. Yeah, you were able to see the quiz grades last week? Oh, then maybe we should. Yeah, let me look into that. Sorry, I can't make decisions unilaterally. Or else everyone will be like, Brian, why did you change this? And I'll be like, I'm sorry. I just made a change. So here, I understand. Yeah, and then if you have an issue where it doesn't take the highest grade, let me know. Or if there's a rounding issue, like if you ever get points off because of rounding, let me know. Like look over your answers. If it's a rounding issue, I'm huge on giving points back, especially with rounding. Like if it says rounded 2 decimals and you rounded to 1, I don't care. Like you obviously know it better than someone who didn't put in an answer. If you were close, you don't get credit. But if it's like a rounding thing, then I'm just like, whatever. Let's go take a look at some Canvas content right here. Oh, no, I'm so sorry, everyone. And I think we have some drops in that, right? I could see us adding like another drop. I don't know. I'll fight for that right there. I'll fight for like another drop. I think that'd be really helpful. Let's put on a little chill music right here. Let's start this up. Canvas content. Here we go. Stat to a 1. Hey, good to see you, our friend from across the sea. Do you want to tell them what you do again? You use R. As long as you're okay with telling. You said it before. You use R and you do medical stuff. But we're doing some side-by-side box plots here. Let's check it out. Good to see you here. Random visitor from across the sea, worth some 50 points right there. And our studio. Yep. Very useful. How useful do you think coding is? Last quick question here. How useful do you think coding is? Like, is it useful to code? Does it help you in your discipline to know how to code, know how to interpret data? Does that help you? I use for biostats and meta-analysis. Yep. Biostats and meta-analysis right there. Came by and visited this summer, and we're glad to have you here. Well, I got a ton of points. You can always check those points and see how many you're at. Oh, you can see your time too. So we appreciate you here and always offering your advice and also advocating for the best packages in R, which we should be using. Just trying to always update what we do. What is the 75th percentile for French teams? So we're looking at box plots right here. With these box plots, let's go look at some box plots. Box plots show us the what? What do box plots show us? Who knows what box plots show us? You should be like, a box plot shows us the what? Box plots will always show you, and I'm going to start highlighting these numbers. This is something we should all know, no matter what level of statistics we're in. Box plots are showing us the what? They do show the IQR. Great job, Tiffany, right there. They do. That's worth some 20 points right there. They do show the IQR. Let me highlight the IQR. That's the IQR. That's the IQR right there. The box plots do show the IQR. This knowledge is not, if not the future, it's the present. All students should have the basic knowledge of data science. Exactly. We actually have a new data science degree at UT. I still like business analytics better. But understanding and interpreting data is huge. You never know. You never know, Snea. You probably will. The 5-number summary, boom, snap, that's worth another 50 right there. Keep answering questions, keep getting points. So wait a minute. We'll put it over here to the side. This is the IQR, like the length of this box is the IQR. That is the IQR. Which the IQR represents Q3 to Q1, the 75th to the 25th percentile. So what is in the middle of this? The median. Great job, Nichelle, right there. Great job. Another 20 points for the chat. The median is right there. So we only have 2 more numbers to represent. Oh, you got it? Great job, Hunter. Excellent work. There's only 2 more numbers to represent. There's only 2 more numbers to represent. What other 2 numbers are there to represent in this? We have the IQR, which is the range of the middle 50%. We have the median, which is between those. The min and the max. Great job, Tiffany, right there. This is the 5-number summary. If you're ever confused on this, the quickest way to remember it is to draw 4 quarters. Just put 4 quarters down on the table. And when you have 4 quarters, you just want to draw five lines. You're like, 5 lines? Well, give it a shot. 1, 2, 3, 4, 5. The highest number is going to be the maximum number in the data set. The lowest number is going to be the minimum number in the data set. The middle number is going to be the median number. And right here, you've added up 1 quarter, and here you've added up 3 quarters. Like literally, you've added up 3 quarters by the time you get to Q3. And the largest and smallest might be outliers. Nichelle, another 20 points. You are correct. This is where a lot of people make mistakes. Tell me a guesstimate, and this is where a lot of people make mistakes. I'm going to highlight something for you, and I want you to tell me, what do you think the maximum is in this box plot? Just give me a guess. Just give me a guess. Pretend this is a test question and we have a margin of error of like 2 or 3. What is the margin of error? Tukey? Talking about some Tukey right there. Tukey test and all those. I mean, what is the, did I say margin of error? What is the maximum for that data set? What is the maximum for this data set? What is the maximum for that group? For Croatia, what is the maximum? Ah, we've tricked you. 20 points, don't worry. This is where outliers begin. That is the highest value that is not an outlier. So that is the highest value that is not an outlier. Always, and this is a good thing, get ready when we do like Kahoots. They're going to pay for Kahoot now. This is the maximum. So outliers can be the maximum. The top of the whisker can also be the maximum. Does that make sense, Tiffany? That's a good, tricky question right there, which a lot of people lose points on. Don't worry, I asked it for that reason. Is that this is the maximum in the data set. This is just the highest value that is not an outlier. And right here, this is the maximum for this data set because why? Why is this the maximum here, but this is not the maximum over here? Why is that the maximum right here? This is the max, but that's not the max. This one is the max because why? This is not the maximum for this group. That's the maximum. This is the maximum for this group. Why is this one the max right here? Because why? Like this is not the maximum for Croatia. This is the maximum. This is the maximum for England. There's no outliers. Houston, 20 points. Great job, Houston. You are correct. There are no outliers because one has a dot exactly, and those dots are outliers. Things that are more than 1.5 IQRs above Q3 or more than 1.5 IQRs below Q1. We're on that in class. So that is how we find the outliers. So let's go look at the question. It asks us, what is the 75th percentile for the French team? So French is going to be right here. Boom. Who knows what the 75th percentile is? The Tukey rule? Which one's the Tukey rule? Which Tukey rule are you talking about? I should know that. So much good advice. Which Tukey rule are you talking about? I feel like that's something I learned in undergrad, and I'm like, oh, I should know that. It's 190. Great job right there. Which vegetable has the highest selling price? I don't know, broccoli. Is it broccoli or is it okra? Is it broccoli or is it okra? And this is a great review of what we just did. Trick question. This will be great. Is it broccoli or is it okra? Trying to trick you. Is it broccoli or is it okra or is it snap peas that has the highest selling price? Ah, you might not. We do different versions right here. This one version does have it. Is it broccoli or is it okra? What does he not use the 1.5 standard for outlier detection? So outliers can be defined many ways. I'm trying to think if he did it for regression or broccoli because it has an outlier. Exactly, broccoli because it has an outlier. I feel like I did the Tukey thing in undergrad with outlier detection. It sounds so familiar. What is the probability of a student being born in Tennessee? Ooh, so let's look. This is what we just covered in class yesterday. So we want to look at the what distribution. When we talk about the probability of a student being born in Tennessee, we want to look at the what distribution. Be careful. Think of a word that stands for something down here or over here. When we want to look at the probability of a student, which means all students, the probability they're born in Tennessee, we want to look at the what distribution of a contingency table. This is a contingency table, which is a bivariate display of categorical data. And we want to then look at a marginal display. Snea, great job right there. 50 points for Stat 474. Hey, Kayla, good to see you here. Oh, yes. Working hard on that presentation still. Not letting any setbacks get me down. The probability of a student. Oh, I did the wrong one. The probability of a student being born in Tennessee. I think they might have the right answer. So this is for the probability a student is born in Tennessee. So we're looking at all students and whether they're born in Tennessee. So the probability a student is born in Tennessee would be this right here. So does that make sense right there? Yeah, that's awesome. And I think Houston's got it right there. Houston, everybody, 20 points. This has been some great office hours right here. I got my energy back. Shouts to BTS right there. There we go. And we want this as a decimal. Did I copy it? Copy. Paste. 3 significant digits. Because, I mean, come on. There we go right there. You got the Oh, of course. I am not. Congratulations. Everyone throw Kayla. I'm throwing 100 points to Kayla out right here. Everyone give Kayla a big congratulations. I am not shocked by that. I am not shocked at all, especially with like the phone interview you told me you're going to have and all that good stuff. I am not shocked. I'm still working hard on my end for the other stuff. I'm hoping, we've hit some setbacks and stuff. But like when I heard about that, for anyone who's in time series right now, is anyone in my class in time series right now? Kayla, can I show your app right after this? Kayla, hang out, and I'm going to show your app after this if you'll let me show it, which you've generally said. The phone call was to offer me the position. Nice job. I didn't know this, but the skills I was teaching students over the summer, so if our friend from across the seas is here, Snea's in time series, we're learning how to use Shiny apps right now. Did your skills from Shiny? I have a question. Why is it... Oh, we're just doing it as a decimal. Sorry, because decimals. If you think there's an issue with that, let me know. So the skills we were learning, TLD, logistics, building a Shiny app for management to use. And I didn't plan this. I wasn't like, everyone's using. Shiny is very good. Shiny is very useful. Shiny is used by many different groups. So that's why I'm teaching Shiny. It's a very kind of new, modern thing. You can show my app. It sealed the deal for me. Your app is like I was saying to you when we were talking, I was like, you should just show them the app and be like, hey, check this out. And then they'll be like, yeah, you know what you're doing. And then they'll be able to tell if you coded it. I don't, but would be great to gain some. Yep. You're about to see something really cool here in a moment. And this is something that Kayla built over the summer. I'll show you to right after this. And it got an internship just like that. Just like being like, yeah, and then they'll ask you, did he ask you to explain some of your app? I'd want to make sure, I'm not saying I wouldn't trust someone that they coded it, but I'd want to be like, can you explain this? Can you show me this? And I'm sure you were able to be like, yeah, so I have these buttons here that do this and connected here with this observe and this reactive and da-da-da-da. And it's obvious when someone knows what they're doing. And Kayla, you coded in R before taking 320. Which I think, did you only take 320 a few semesters ago? For those worried in 320 right now or 474 who are watching, you've just gone, you're now doing an internship that's using it, and I'm just very, very proud. It's proud father moment. I'm not a father. We'll take a look here at Shiny in a second. We'll finish off the quiz. Below is a contingency table of students. I went through every aspect of the app. Yep. Yeah, that's totally it. Yep. Below is a contingency table of students born in students by or they're an honor students. What is the probability of a student born in Tennessee being an honor student? So we want to look only the students who are born in Tennessee, only the students who are born in Tennessee, only the students who are born in Tennessee. So you only started this year. Wow.
Wow.
And it's a serious. That's more like a only the students who are born in Tennessee being an honors student. 50 out of that's got it. That's so awesome. So 50 out of 574, the probability of being born in Tennessee and being an honor student. What is the probability of a student born in Tennessee being an honor student? 50 out of 574, and we're showing it right here. 50 out of the 574. That's a conditional distribution. I better get 100. No typos. Times that by 100, and we want this to 8.71. We're going to finish this off with a little shiny right here. Below is the contingency table. What percent of Marvel superheroes have the ability to fly? I want to make this smaller. So this is a what distribution again? What percent of Marvel superheroes have the ability to fly? This is a what distribution again? What percent of Marvel superheroes have the ability to fly? Important word we know. I was just saying it a second ago. This is the percent of Marvel superheroes that have the ability to fly. This is a what distribution? Just ignore everything else. This is a what distribution? What percent of Marvel superheroes have the ability to fly? This is a what distribution right here. The percent of Marvel superheroes. So of the Marvel superheroes, what percent have the ability to fly? That is a what. And that is the correct answer. Great job, Tiffany, right there. And that's a what distribution. Oh, yeah. The R community just continues to grow. Python's great also, but everyone knows I'm a big fan of R. This is a conditional distribution, and it wants it out of a decimal. Please tell me I made no errors. No errors, no errors, no errors. Let's check it out. Watch me have gotten rounding wrong or something. Yes, 10 out of 10. I got a little bit afraid. Never be scared. It's a conditional. It's Houston right there, 20 points. Great answer, Houston. It is a conditional because we're setting a condition where, so Houston, another 20 points. Just to remember, where are the marginal distributions? Like, where do we see the marginal distributions? And we're going to look at the shiny up here. Where do you see the marginal distributions? The marginal distributions on a contingency table are where? So Houston, great job. Remember, the marginal distributions are where on a contingency table? The marginal distributions are where? Kayla's giving a huge shout out to the Discord. We are the second largest UT Discord. So make sure to do for everybody. It's basically the totals. Yep, that is because it's in the margins, Houston. Great job right there. It's in the margins. And we'll come back. We might do another version of this real soon here, Tiffany. We have here a conditional distribution. We'll do another version of Canvas content after this. And I think maybe 474 had another one. Can you do the above question I have on my Canvas content? Yeah, let's do one really quick. And then we're going to look at the shiny. Let me see right here. We'll do that one. Got to find it. Got to find the chocolate one. Got time for one more. Where's the chocolate one? No. Ooh, we got to find it. Game Day got you fired up. Nice job. Heck yeah, Game Day. Up, here we go. Below is a contingency table of some flavors of chocolate along with the ratings. What percent were neutral about the chocolate they tasted? So does that sound like a conditional or marginal? I need your help. It says what percent were neutral about the chocolate they tasted? Does that sound like a conditional or marginal? If I say what percent of the people were neutral about the chocolate they tasted? What percent of the people were neutral about the chocolate they tasted? Does that sound like a conditional or a marginal? It is, Tiffany, you're right. So is it conditional or marginal? What percent of the people were neutral about the chocolate they tasted? Is that conditional or marginal? And so your answer is right. So is it conditional or marginal? Marginal, yes. Nice job right there. That is a marginal because it's in the margins. And so that's going to be this right here because it's in the margins. So remember, marginal is in the margins. Condition would be like, of the people who were neutral, what percent of them had extreme dark chocolate? So you'd have to do like, given someone was neutral about the chocolate, what's the probability they had extreme dark chocolate? Let's go check out the app right here. So give me 2 seconds. Do I have the work saved from today? Let me save this. This is BAS 320, second. Okay, I think I've got everything saved now. And then let me reload. Okay, so I'm going to go and grab the app right here. Oh, okay, that's so awesome. I see. That's so awesome. That's awesome. I guess I'm not the best at that stuff either, to Kayla's question, to Kayla's other question. I don't know. I don't know answers to questions like that. I wish I knew. It's a very good question. I think that's something we should always, to your question, Kayla, if you know the other question about the numbers. I guess, I mean, it's always better when it's bigger, yeah. Okay, I'm getting everything loaded up right now. Boom, we got it good to go. Okay. Yeah, I know, like, that's always a good question. Okay, so this is Kayla's app developed over the course of 1 month. 1 month. Oh, thank you so much there. I appreciate that. This is 1 month. We're going to select our vector right here. We're going to go to the frequency tab, and I want you to see something when we go to the time series data. This is the data we're working with right here, and we loaded it in. I loaded in the data, so I've loaded in my data. I'm going to go to the time series data. I'm going to go to the frequency of it, and I can select if this is weekly, monthly, quarterly, semi-annually, and look, it changes the data. So now you can see the January 2000 data. You can see all of this right here, and Kayla, tell me if I ever miss anything. You can select it to quarterly data, and it's just changing the way the data looks, and it's showing you what the vector is. So it's actually doing the time series function. Nice job, Tiffany. It's a dashboard. Yep. And Kayla's got, we're not going to use this yet. We'll worry about that here in a moment. We should have, let's see right here. And here's the start date. We could change the start date. Like if our data were to start, you can actually change the year a lot quicker if you do this. Like let's say this is 2010 data and it starts in November of 2010. We can select November 2010, select the first date, and guess what? When we go back here and look at our data, it starts at November 2010. So we can load up our data. We can have it looking at what year the data is. Someone could just send us data. I was trying to get dashboard on the week group, but syntax kept messing me up. We can always talk to Kayla. Kayla's a pro at this. Like, I truthfully look at Kayla's app for advice sometimes and be like, how did she do this? How did she do this? And I have a hard time thinking that I taught Kayla. I'm just like, Kayla was finding so many things for us and being like, check this out. One of my favorite things about this class was Kayla found something that had been like updated like a month before. Kayla was like, I didn't even know this existed. And she was like, well, they just updated this package like 1 month ago. And I was like, oh, that's why. Because I probably looked like 2-3 months ago and I didn't see it. So Kayla's using literally the latest and greatest stuff right here. And you haven't even seen the half of it. We have here the holdout. This is the percent of data we're holding out. Very important for predictive modeling. Friend from across the seas, do you need a holdout to test your model? Should you hold out some of your data to test your model? Friend from across the seas. I'm sorry, because... yeah, that's what I refer to the gentleman as. Should you hold out some of your data when you're making a test? It was 10 days before our class. It was 10 days prior they had released updates that I was like, I didn't even know that existed. Let's go look at this model. Here's our model, and we've got parameters for transformations. So you can see the percent of data we're holding out. We could change that right here and change the amount of data we're holding out. We can also look at the forecast we're getting for different models. Let's go ahead here, and why not just go auto ARIMA on it? And it takes a moment, but now it's doing the auto ARIMA and looking at the forecast. And we can actually see the forecast, the held out data, that's the test data right here. Here's the fitted data, and you can see our model is actually doing worse. We can even go in here and do some differencing. And if you take a look, we have now differenced it. Everything should go fine. It's doing a lot of calculations in the background. There we go. There's the differencing, and that's going to make it more of a stable process, right, or a stationary process. We still see, we probably need that lambda transformation because we're seeing an increase in the variance. The model does so good at the start. So let's just throw a Box-Cox lambda transformation on this. That's going to optimize. Ooh, that's looking a lot better. Model's still not doing great at the end right here. And this is the auto ARIMA procedure. We're starting to get something closer to a decent model right here. Model does really great at the start. There's lots of other different models we can use right here. We're just going through the auto ARIMA on it. Yeah, no, that's Snea. That's exactly Snea. You might be right up there with Kayla after this. And here's the values. These will auto do. We can change these right here. This is so many. You can change your seasonal model just right here to different types of different models. We might not have that on. Kayla can tell me if I'm using her app correctly right here. And then we go over here to the check residuals to see how our model's currently looking. Man, look at the start of that model. Ooh, I see something. If you know how to read this, let's go to the PACF. So now we have this right here where we can go from our ACF. This just has the ACF and the residuals, which are pretty normally distributed, which is good. The model is so good at the start. I'm even wondering why it is so good. Should we do the exponential smoothing with Holtz-Winter or Holtz-Winter? Yeah, because we've got a seasonal model, so Holtz-Winter, or at least Winters as part of it, is going to do a lot better. The model does so good at the start, and that's weird. And that's almost not good that our model does so good, and then we see something weird. The model is just so well fitted at the start, and that's weird that it's so good and then it gets bad. The partial autocorrelation, we have something appearing here on lag 4. Do I have this set as quarterly data right now? This is quarterly, right? I think I made a mistake, and I don't have this set as quarterly data, which is kind of evident in this, that this is quarterly data. Up, and look at that. There we go. This is quarterly data. This is quarterly data. You have to know your data. You have to make sure you're doing your data properly. So now this is being analyzed as quarterly data, and the lag 4 right there was really indicating. Now here's a big important thing. This right here is a little high, which means the what? What does it mean that it's outside these blue markers? That if you've taken time series, you know that anything outside this blue marker is what on a lag? I know, right? This is kind of a big review of time series right now, where you'll be at the end. Anything outside these blue markers means that the lag right here, the autocorrelation right here, which is correlation on itself on lag 7, is actually a little bit too high, because this means its p-value is what? This would represent p-values what? You can add, please email me about XGBoost on Arima. Is that through Carrot or whatever? We'd be very interested on. I'll have to look into that XGBoost, extreme gradient boosting on Arima models. I have not done an extreme gradient boosting on Arima models. I have not done an XGBoost extreme gradient boosting on Arima models for parameter estimates. No worries, Kayla. Don't worry. This means that the lag right here is statistically significant, but that's so small, and that we've got 20 autocorrelations here and partial autocorrelations. That's probably by what? You know what's going to happen here. That's probably like a p-value of 0.05, and I know that's 0.045 or something. That's probably just by what? Because we've done a lot of tests here. We've done so many tests that statistical significance that those might have is probably just by what? Even though it's like 0.046. It's probably just random. It's nothing big. We've probably captured most of the variation. Not saying this is the best possible model. It's probably just by random chance. The further away it is, because if we make a really bad model right here that doesn't capture the variation, like if I turn off the auto Arima, if I turn off the transformation, we set everything back here to the original and we look at the residuals. Now, whoo! And Kayla should know the first thing we're going to do right here when we see that we have this kind of decline in the ACF, probably the first thing, which I should have done first. I've worked with this data before. The first thing we want to do right here is probably do some WUTting to this. This right here on the ACF, probably the first thing I want to do is start doing some WUTting to this data, because we've got a trend in the data right now. We've got a linear trend. So probably, oh, Snea, that's so cool. Close. That's kind of what we're doing. Very close. Snea, 100 points. That's kind of what we're about to do. Differencing, yep. We're going to throw some differencing on this. Differencing basically takes the difference between ones. And this is actually where we're going to see that we want to probably throw the lambda. The lambda Box-Cox transformation is going to remove out the heteroskedasticity. Heteroskedasticity, 320 word for differing spread. Stat 201, does the plot thicken? So now if we look at the residuals right here, we see a different pattern, and you're mainly seeing a huge thing on the what of this. Now we're seeing, because remember, this is quarterly data. What's the big, like, low-hanging fruit right now we see? So what is the big, like, ooh, we should deal with that? Like, I really see probably when we want to deal with the what of this data, because it's quarterly. Yeah, HDT 50 points. Differencing will get us the difference between each one. So it takes like, if you were to take the vector 1, 3, 8, the differencing on that vector would be 2, 5, because it'll take the differences between the points. So you'll get a time series of the differences between the points, like when you look at the first order differences. So we do first order differences or second order. So if you still have a trend, you could do a second order difference, and you could, if you still have a trend, do a third, but then it gets really weird. And the seasonality Kale is pointing out, and we do start to see a decay. We see a decay right here. So what is it? MAAR, right? So wherever the decay is at. Oh man, I always got to check, and sometimes I just run them both and take a look. But we're seeing the decay in the ACF, and we see it just drop off here in the PACF. So we could try certain things here. Like I could go back to here, and on the seasonal, does this have the seasonal component? These are the ARIMA controls here for this. I don't know if you have the seasonal ARIMA. Do you have a seasonal ARIMA, Kayla? Because we need the seasonal ARIMA component. Wait, let me go type a model. Ooh, seasonality. Oh, no. Sorry, I broke it. Didn't happen. You didn't see anything? Nothing happened. We're always trying to... Nothing happened right there. Let's go type a model. Oh, that's maybe why. Airplane. No, and Kayla, this is absolutely amazing. We got all different models right here to use. We just loaded back up the data. All the different types of stuff right here. If you look at the different forecasts, and I want to point out so we're doing right here, let's change the type of model again. We've got the drift model right here. We've got right here the mean model right here. All different types of models that you can bring. The naive model right here. All the different types of models we're going through. Holtz Winters. And I guess maybe it's because oh no, so you'll have to tell me, we'll figure out why that's doing that. We could take a look. Sometimes the integration causes the app to crash, don't know why, yeah. And that's where we could try to debug it and everything. So I might be causing it. I'm subbing in for Lucy. Here's what's so amazing about this though. One of the most amazing things about this, and I just want to say Kayla went so far above and beyond with this right here, is that as you go through and you make your different models, what's so cool about this is that as you're making these different models right here, I've totally just made everything go haywire. There we go. Oh, I was on quarterly anyways. As you go through and make your different models and you look at them, it stores a list of all... That library is loaded though, right? It stores a list of everything you have created, and then you could sort by how it's doing. So you could look at your RMSEs on all your trainings and all your tests. And so I was telling Kayla we could put Kayla, so don't worry. Kayla's like, okay, gonna get it done now. Or maybe you could just go right here and just go to test. Well, there you go. Kayla, that's how you subset it right there. If you just want to look at how things are working on the test data, you could just put here search for test, and you don't have to write a subset function anyways. You can just search for the test and see what data is working best on the test. So as you go through here and you make your different models, you can just start making different models right here and see how they're working and just click through them. And as you're doing all of this down here, at the very end, you can go down and you can check your accuracy and bring up just your test models and then sort your accuracy, and the Holtz model was doing the best. Yeah, that's it right there. Sometimes the solution's like, well, why code it when it's already just obtainable by doing that? Because we've got a search feature. So there you go. And this is just working with Kale's app. When you're finished on this, can you go over 8C? I think we'll do some 8C. Yes. Might down the road today. We'll do that here too. I think we'll end with that. But we can go to the predictions right here. Here's the predictions for the upcoming quarters. So you can see the upcoming quarters predictions, and they probably want to go and select this model. So all this was made over the course of one summer semester, and this is this is what blew my mind. When Kayla did this right here, and you can add this to the accuracy table, but once Kayla did that, I was like, no way. I've never seen an app do that. And we can even go into change the smoothing cycle for the low smoothing right here on the trend cycle low smoothing. Absolutely insane. Absolutely amazing, using the ARIMA to do that, and then we can make predictions with this, and it's added to the accuracy table. So we could look at how this is doing. That probably did better. We should always kind of know what we're doing. The Holt is still doing... Oh, wait. Yeah, the Holt model. Do we not have Holt's Winter? Where's my Holt Winter? Let me go to the model and get a Holt's Winter. It's probably the auto on them. Holt's Winter. It's here. Check accuracy. The model that is working the best. Ooh, Holt's Winter is not working the best? Wow. How is Holt working better than Holt's Winter? There you go. There you go. If you really want to get fancy, you could start using 474's one standard deviation rule. I know this is amazing work. I was absolutely blown away by this. And just so you know, and I can't imagine coding all this, you can see all the libraries loaded. I'm not going to show the full code. I'm just going to show the very end of it, which really doesn't give everything away. This took a long time to code. This is 735 lines of code. You can see the data table at the end there with the predictions. But 735 lines of code. Absolutely amazing, and hadn't done any coding in R before this year. This warms my heart. Let's head back to the main screen. I'm amazed. If I had to sit down and write that app, it would take me a long time. And that was all just done in, little bits right there. I think we had a question on 474. We're going to finish off with that. The question was... Where was it? 8C. Let's do some 8C to end off today. 8C 474. Kayla, do you have any advice for them? Kayla, I want you to give them all the advice you have. And Kayla, were you afraid about coding at the start when we started 320 and you got these really hard assignments? Was the first assignment in 320 hard? Like, on a scale of 1 to 10, wait, Kayla, answer this. On a scale of 1 to 10, I'm throwing like all these questions. How hard was the first assignment in 320? 1 to 10, 1 being like it was a joke, 10 being it was super hard. How hard was the assignment? And don't answer any way that I want you to answer. 1 to 10, I was terrified at first. And a 1 to 10, 1 being, that was a joke assignment, Brian. 10 being like, that was impossible. 1 to 10, how hard was that first 320 assignment? Snea saying an 8, who's in 474 right now in 475. Snea says an 8. And Kayla is saying it was a... Oh, yeah. You're talking about the knitting assignment might be super easy. 8-ish, I think you're talking about the other one. And now Kayla has coded... Hunter says 9 for sure. Kayla has coded... If you look right here... Right there, just amazing. Amazing. And all this is done just over time, over practice. You're not going to code it in one day. I just keep saying that. It's like trying to get muscles in one day. Not going to happen. Not going to happen. Some algorithms. I think we're doing this one right here. Is this 8C or is this 9C? This is 9C. We're looking at ones that violate the condition. Let's look at this right here. We'll finish off with this question. 8C, last question of the day. Go to class, go to officer, data camp, obsession, passion. It was hard and I had no idea what I was doing. This is all from the 474 crew telling 320, you got this. And just practice, ask questions. Ask questions. Whenever you're stuck, be like, hey, this won't work. I'll try to get to every question as quick as I can. Sometimes it takes a second. I will answer. I try to answer every email before going to bed and answer every Discord question. The last part right here, the last bullet point. So when stock is either in low or high. So let's write a condition right here. So I want to check to see if the stock is contained in the vector low or high. Thank you so much, Hunter, right there. Thank you, Hunter. So we want to see if stock is contained in low or high. Oh, Hunter, you're the best. Thank you so much. We want to see if stock is contained in low or high, or in or low. And here's the hint, I'm saying it. We want to see if stock is contained in That's a much better way of writing it. Thank you so much, Hunter. Some 20 points for all that positivity. We want to see if stock is contained in. Great job, Kale, and congratulations again. Great job. You can. Oh, be careful. So HTTP, that will work. If we do this... Wait. My brain broke. If stock is equal to this, that tells if its stock is equal to that. Or if stock... Oh, here we are down here. when it's lowercase low, watch lowercase in. That works. You can do that. There we go. That's the way I would do it. This, and we can check these right here. I would do it rather with contained in. I'd rather do the %in %, which means contained in %in %. And this is going to look to see if anything in the stock vector, and great job right there, 50 points answering questions, practicing your code. We'll go right here and go, is it contained in these? Now we can see if we get the same amount by putting a sum around this. I'm just going to put a sum and see how many there are. And this will confirm that this is doing the same thing, or at least a good guess that it's doing the same thing. Like, we wouldn't know for 100% certain because there can be very similar code, but it is doing the same thing. Much easier to do this, especially for longer vectors, rather than doing is stock equal to this, or equal to this, or equal to this, or equal to this. We can just see if the value of by $stock, which is a character vector, might be a factor. Let's see here. By, where's the by vector? And stock is a factor, so it is a categorical variable. And so with this right here, we only have one more part of this to write. Oh, Olivia sees it. Nice job. And now we also want to see that it says it's violated when stock is one of these, it's in or low, and sellers is equal to 0. So Olivia, finish this off right here for office hours. What are we going to write to see also that the sellers are equal to 0, which is when it violates it? What are we going to also write right here? So Olivia or anyone else, we also want to see if the sellers is logically equal to. I like to say 2 words for logically equals. Because that's how we're doing the test, to see if something is logically equals. Yep, we want to join with an and, another condition. And then we want to go to the by data frame, and then we can go to the vectors inside of it. Sellers equals 0, and that's got the condition written now. This will give us a logical vector. And then what can we do to logical vectors? Great job, Snare, right there, everyone. Because everyone knows that R sees trues and falses as what's and what's. And be careful, Brian sometimes codes more than you need, but R sees trues and falses. I try to put disclaimers on this. I do a bunch of extra work so people can't just write the one thing. R sees trues and falses as ones and zeros. And great job right there, Olivia and Snare right there. R sees trues and falses as ones and zeros, so we can just sum them up. And we can figure out how many trues there are, or, wink, wink, the amount of things that violate the conditions. So that would be the %. We could change it to % if we really want. We could always round it, or all this good stuff right here, but we just have right here and you don't need to do this. Grader might get mad at you. But that right there is 1.82% of things violate the condition. And that's got it. Great questions. Good work. I think that's got it. Take a little break right here. Going to be teaching what in 11 minutes? Oh, gosh. Ah! Well, we'll be teaching here in 11 minutes. So you know what that means. It's time to head off. I'll be seeing Snea and everyone soon in 475. You don't have to round. Just hint, hint. The question's really only looking for the % that violate, a number between 0 and 1. Always try to answer exactly what the question answers. Graders might get mad otherwise. I'll be pretty nice if you say, hey, Brian. But be careful. I do write a lot of extra code, so I will do extra things. So I might not do exactly your problem, or I might do some extra stuff. That way people, you can have to watch and be like, okay, what are we coding here? What are we doing? Because I don't know. I don't want people to copy exactly what I write. I want people to be like, what am I writing? What am I doing? And with that, be seeing everyone soon in 10 minutes. Bye for now. Bye! I hit my light. I don't think I broke anything, though. Bye, everyone.